All right, so we have to find the standard deviation of this discrete probability distribution that we were given. Um, and so you may notice that I have put it into a table and I have made a couple of columns, and these columns are important to the process, otherwise you can't do it. So the first thing we need is to take the two initial columns that we were given in our probability distribution and multiply them together. So 0 times 0.69 is 0. Now, of course, you did this as you were finding the mean, but this is also part of the process of standard deviation. And we could take a shortcut, but just in case you're given a problem where the only thing you want is the standard deviation, let's realize you've got to find the mean first as well. So 1 times 0.15 is 0.15. 2 times 0.08 is 0.16. And 3 times 0.05 is 0.15, and then 4 times 0.03 is 0.12. And then we have to add all of these up to get the mean. So the mean, I'm just going to put it right here in this cell that's below these. If we add up all of those, I believe that number was 0.58 that you already got the right answer to. Let's just go back and double check that I added those correctly. Yeah, it was 0.58. Okay, so let's go back to where I was working on the standard deviation. Okay, now the next thing we need is this column of x squared. So we go back to our original discrete data here in our outcomes right here in the very first column, and we're going to square each one of these. So if we square 0, 0 times 0 is 0. And 1 times 1 is 1. And 2 times 2 is 4. And 3 times 3 is 9. And 4 times 4 is 16. All right, now to get this last column, we're going to multiply this column that I just made times the probability column right here. So 0 times 0.69 is still 0. 1 times 0.15 is 0.15. 4 times 0.08 is 0.32. 9 times 0.05 is 0.45. 16 times 0.03 is 0.48. And now I add this column up. And let me just put this into my calculator and we'll see what we've got here. 0.15 plus 0.32 plus 0.45 plus 0.48. That is 1.4. All right, so now what we do is we take what we got there, 1.4, and we subtract the mean squared. All right, so let me square the mean. Let's see what 0.58 squared is. Except I can't type well, apparently. 0.3364. And let's do that subtraction. So 1.4 minus 0.3364, that is 1.0636. Now, this answer that we just got is the variance. To get the standard deviation, we take the square root, and rather than taking the time to bring that symbol up, because it does take a while on here, I'll just write square root. So I'm going to do the square root of 1.0636, and I get 1.0313, and there's a lot more decimal points. We'll see what it tells us to round it to. All right, so there is our standard deviation. If we go back to the problem, let's see, we were to round everything to 2 decimal places, so it's 1.03. Okay, so hopefully that helps with that. I'm going to turn this off and then pull up the other questions you had. Okay, so let's look at the second of these. A bag contains 9 white marbles, 10 red marbles, 6 white marbles. or 6 black marbles. If 2 different marbles are drawn from the bag, what is the probability of drawing a white marble, then a black marble? Okay, so let's look at the white marble here. Okay, so there are 9 white marbles out of 25 marbles. So that will be 9 out of 25. All right, so let's go back here. We're going to have 9 out of 25 for the first marble. But we have now taken a white marble out of the bag. So keeping that in mind, let's go back here. We've taken 1 white marble out of the bag. We now want to know what's the probability of a black marble. There are now 24 marbles in the bag. So 6 out of 24 for the black marbles. And then let's let our calculator do that, and that will give us the probability. Okay. And that ends up being 0.09. All right, let me find that last problem. Okay, so we have a CBS News poll was conducted among a nationwide random sample of 651 adults. It asked those adults about their party affiliations, Democratic, Republican, or none, and their opinion of how the U.S. economy was changing. Getting better, getting worse, or about the same. The results are shown in the table. Suppose one of these survey respondents is chosen at random for a follow-up survey. Okay, so we want to find the probability of choosing someone affiliated with neither party. All right, so let's notice this last row is all of the people affiliated with neither party. So we will add up everyone in that row, 21, 90, and 118. We will take that sum, whatever it is, and put it over 651. And that will be the probability of choosing someone affiliated with neither party. For B, what is the probability of choosing a person who says the economy is about the same? We will look at everyone in this column, the people that said it's about the same. We will add up all of those people that are in that column, put that over the total of 651, and that will be our probability that they are saying that the economy is about the same. All right, now C is a little bit more complicated. What is the probability of choosing someone who thinks the economy is about the same if the person is someone affiliated with neither party? Okay, so first, this fact that we've got somebody affiliated with neither party to begin with changes our sample space to these people in this last row. So if we add them up, 21, 90, and 118, 21 plus 90 plus 118, 229 people in that last row. That's our new sample size. Out of those people, we want to know who thinks the economy is about the same. So out of those people in that last row, the people who thought it was about the same was these 90 right here. So it's 90 out of 229 for that probability. Now in D, the person chosen thought the economy was about the same. What is that? The chance that that person is someone affiliated with neither party. Okay, so this one, given that we know they thought the economy was about the same, we want to know what's the chance that they are affiliated with neither party. So what we have to do first is restrict our sample space to people who thought the economy was about the same. That's these people in this column here, 104 plus 87 plus 90. That is 281. So our sample space size is now 281. And out of those people, which ones thought that the were actually affiliated with neither party? Well, there were 90 of them affiliated with no party, right here. And so we only need 90 out of the 281 people that were in this column. So 90 out of 281. E, to determine whether the events person is someone affiliated with neither party and person thinks the economy is about the same or independent, you could compare the probabilities from which parts of the above. Okay, so two things are independent if the probability of, let's say, well, let's sort of abbreviate here. Let me go back here. So they will be independent if the probability of the non-affiliated people, not in the same party, is equal to the probability that they are non-affiliated, given that, let me look back at the situation again, get the language right. They think the economy is about the same. If this is true, it is not independent. All right. And so the opposite is also true. If the probability that the economy is about the same is equal to the probability that the economy, they think the economy is about the same, given they are non-affiliated, then we know the independence. So let's go back over here and let's see which of these two calculations we actually did. So we did affiliated with neither party in part A. We did their economy about the same in part B. So, and we did in C, the probability that someone thinks the economy is about the same, given they are from the not affiliated with either party. So that actually will go with B. So C and B go together. So let's see. There's that calculation. And then the last one, the person chosen thought the economy was about the same. So given that it was about the same, what is the probability they're affiliated with neither party? That is going to go with A. So A and D is also we could look at, but that, yeah, it is one of our choices. And it said, of course, to select all that apply there. And I'm going to take those off of there because this is your homework too. But those are the two that we would have to choose in those two places. And hopefully that will help.